Welcome to part 3 of our chapter review. I've divided this into 3 short sections, and today we are going to pick it up on, or in this section I should say, we're going to pick it up at number 9. And in this case, we are applying the fundamental theorem of calculus part 1 to find the following derivatives. So if you're like me, sometimes I'm in too much of a hurry to just get started with the problem, and I'm thinking I'm taking an integral, but I'm really taking the derivative of the integral. And derivatives and integrals are, for the most part, just inverse functions, other than that we have to deal with constants at times. So I'm taking the derivative of the integral. I expect that to be undone, but I've got to rectify this whole t situation in this. A little bit of an issue with this because we're discontinuous at 0. We have a point of discontinuity at 0, although that's an endpoint. But it's going to go away for the purposes of this problem. So when I take the derivative of an integral, basically the integral's gone, but I have to put x in, my upper bound, n for t. I get 1 on x times x's derivative, 1. Well, you say I don't need that. Well, that's true, but it's a good habit to get into. And then I get minus put in the lower bound, 1 on 0. There's our issue, but if you notice, times 0's derivative, that goes away, and I just end up with 1 on x. Okay. So, but you have to be alert to that chain rule step right here. Now we see that when we chain rule this, we're going to end up with a times 2 at some point, but the derivative, our dy dx, is going to eliminate the integral, but we must put 2x in here, and we get cosine of not 2x squared, but 2x squared times the inside derivative. What did I put in? 2x times 2 minus the cosine of 1 squared, but times 1's derivative. I think it's a really good habit to get into. I realize 1's derivative is going to be 0, and anytime we have a constant here, that minus portion of this is going to go away. But I think it's probably a pretty good idea until you're 100% comfortable with this. Just go through the process, because who knows when this is going to be 3x squared down here instead of 1, and then the minus portion will survive. So we end up with 2 cosine of 4x squared. The derivative of 1 is 0, so that is it. 2 cosine of 4x squared. Okay, we did very well on that on the quiz, but there's some traps, things to look out for there. Make certain that we're considering the derivative of 2x at some point and the derivative of our lower bound as well at some point. Okay, which leaves us with a couple problems here. Find the average value of, so let's take a look at that one. When I'm finding the average value, they are talking about the y values, and again, it does not really matter when I'm finding the average value. It's not asking about the areas, so I don't care if between 0 and 1 this function happens to cross 0. If I was asked for areas, I have to consider between 0 and 1, is there a 0 to this function? So at what point in the interval does the function assume its average value? So the average value, well, we find the areas, or excuse me, we find the integral. But to repeat what I talked about in an earlier portion of this review, this is y, this is x, and all of those y-x's are basically our tiny, tiny little width, theoretically 0 rectangles. And we add all of those up. But I only want to talk about the y's there. So Mr. Hartz's example would be, let's say we have a function like this. Well, if this was an ice sculpture, let's just say we were going from here to here. I'm looking for the area in there. If this was an ice sculpture in here and we let it melt, it would melt into about that rectangle where this overage would fill that gap. And so our area is x times this would be our average height. So we need to divide away this value. So that value in this problem is from 0 to 1. We just need to divide by 1. I'm telling you that we're going to change that problem right now. I'm going to change that to 3 just because I worry if you see this and you don't pay attention to it, you're just going to think that the integral gives us the value. So we're going to divide by 3 That's 1 on 3. So we get 1 on 3 times, if I end with an x squared, after taking a derivative, I started with an x cubed. That gives me 3x squared, but I need that to be negative. If I end with negative 1, I started with a minus x, and I'm finding that from 0 to 1. Or actually, 0 to 3, we're going to say now. 0 to 3. So again, I'm going to give myself a little bit of room here. Probably need a couple lines. 1/3 times all of them. I'm not going to forget that 1/3. I get negative 27, not to the 7th, negative 27 minus 3, minus, put in 0. Okay, I get a big old 0 here. I end up with 1/3 times negative 30, or negative 10. So our average value equals negative 10. That's our average height of this function between 0 and 3. Have to include that division or multiply by 1 on b minus a, 3 minus 0. Okay, a diesel generator runs continuously, consuming oil at a gradually increasing rate until it must be temporarily shut down to have the filters replaced. So here we've got our days, Sunday through Sunday, oil consumption rate, liters per hour. Use the trapezoidal rule. Our trapezoidal rule says that our trapezoidal area is either the average of LRAM, RRAM, or it is, if you're going by hand, which you're going to do on this test for this, h on 2 times y0 plus y1, plus 2y1 plus 2y2 plus ... until I get to the last value, and then it's just a single one of those. But all the values in between are 2's. Now, we went through that in a previous video when we were talking about this section, so we should be aware of this one. And it really is pretty handy little method of finding our area, particularly from a chart like this. So our h is, we've got trapezoids under our area, might look like this, but our h is the height of the trapezoid, and the trapezoid, if we looked at it this way, our h is just our increment. So our increment, if they said anything about hours or anything like that, we might need to convert to 24, but our increment is just 1. We're just 1 day. So our trapezoidal area is 1 divided by 2 times, this would be the left side of our first trapezoid, this would be the right side. So this would be our y0, y1, etc. So we just get 0.019 plus 2 times 0.02 plus 2 times 0.021 plus 2 times 0.023 plus 2 times 0.025 plus 2 times 0.028 plus 2 times 0.031, careful, just plus 0.035, and I'm going to go back and double check those. 0.019, 0.020, 0.021, 0.023, 0.025, 0.028, 0.031, 0.035, and I'm going to leave the rest of the, I'm going to leave the calculator work to you. What I will not accept on the test is just a solution for t, because I will assume you got that from your trapezoidal program and that you've written into your calculators, but by all means use it to figure out, use your calculator to figure out if your final answer here is in agreement with it. So that is it. We'll be looking at a test a day and a half on this one, and good luck.